Alright, hi and welcome back for our educators. So today I'm going to continue with part 2 for 2.3 atomic structure. Okay, so in last class I stopped at here. So I want to explain again. Atoms of different elements have different proton number. For example, sodium atom, their proton number is 11. But for chlorine atom, their proton number is 17. Yes, correct. You see your periodic table, you have every different element. For magnesium, the proton number is different. For chlorine, the proton number is different. For sodium, the proton number is different. For lithium, the proton number is different. So every single element, they have their own proton number. Proton number won't be same for any elements in this universe. They are always different. Okay, why different? Because you know, right, proton and neutron, right? So memang it was like in the science itself they stated that whatever element you have in this universe, their proton number won't be same because their characteristics is not the same, something like that. Okay, and now see, I mentioned you this word earlier. An atom is neutral. So what is they're trying to say with neutral is the electrons is same with the number of protons. Please underline this statement. Okay, an atom is neutral when the number of electrons is same with the number of protons. So whenever they say it is an atom, you must know if they have 13 protons, meaning that they have 13 electrons, because they are same, they are neutral. Neutral means zero, meaning that you plus your proton and electron, because proton and electron only have charge, neutron don't have charge, so you must get zero. Okay, so let's say I have positive 14. So how many electrons I should have to get 0? For sure I need to have negative 14, then only I can get 0. This is normal mathematics that you learn during your lower secondary. Okay, so please highlight this word and I write for you at here. An atom will be neutral. Why atom is neutral? Okay, because, okay, I write for you here. Number of protons equal to number of electrons. Yeah, so this is the key that you must understand. Okay, P equal to E in atom. Okay, so let's read this first example. Okay, an aluminium atom has 13 protons and 14 neutrons. You see, they say aluminium atom. Highlight the substance, aluminium atom. So whenever they say atom, proton and electron is same. So they have 13 protons from what you read. So how many electrons they have? Yes, they have 13 electrons. Very good. Okay, and then how many neutrons do they have? 14 neutrons. How I know 14 neutrons? They already state for me in the question itself. Okay, now what are the proton number and the nucleon number? Okay, so now I ask you in terms of definition from what you learned in your previous first lesson, what is proton number? Proton number is the number of protons. So how many number of protons? The question itself give you the answer 13, because they say they have 13 protons. And they say the proton number and nuclear number of an aluminium atom. Atom means just refer the up. Okay, so your proton number is 13 also lah. So you can write, sorry, why do I use a highlighter? Okay, proton number is equal to number of protons, right? So equal to 13. Done. Then they ask nuclear number. Okay, what is the formula for nuclear number? I mentioned in the first lesson for you. Nuclear number is P plus N, which is proton plus N, correct? This formula, number of protons plus number of neutrons. So I have how many protons? 13 protons. I have how many neutrons? 14 neutrons. So plus lah, 13 plus 14. So I have 27. So this is my nuclear number for aluminium atom. Okay, you see how I determine? Always to get the number of protons, electrons and neutrons first, then you proceed. Okay, so this is a very simple question which won't take so long for you to understand. Okay, it's just a very easy concept only. Okay, next question. Okay, I bring it top a bit. Okay, I think it's super good now. Alhamdulillah. Okay, fine. So the nucleon number, okay, let me to close this side textbook. Okay, so the nucleon number of potassium atom, okay, potassium atom, meaning that proton and electron is the same, but this one they say nucleon number. So nucleon number haven't. What is nucleon number? P plus n. So P plus n equal to 39. How I know 39? Because they say, and nucleon number is just P plus n equal to 39. And they say a potassium atom, highlight potassium atom. Atom means proton and electron is the same, has 19 protons. So they have so they have 19 protons. So they have how many electrons? They have 19 electrons also, because it is an atom. They say atom what? You see, they mention the word atom. So in atom, proton and electron is just the same. Understand? How many neutrons and how many electrons there is in a potassium atom? Okay, so first you calculate first the neutrons, because they ask with neutrons, right? So they have 19 protons, so 19 plus n equal to 39. So my n is 39 minus 19, so n is 20. So if people ask me how many neutrons they have, or you can say like this, you want to answer scientifically, you can say potassium atom have or has, it has 20 neutrons. Simple, very easy. Okay, and they ask about electrons. What I say about electrons for you in an atom, proton and electron is just the same. So you can say potassium atom have 19 electrons. Why they have 19 electrons only? Because they are atom. Atom means proton and electron is the same. So I hope you understand by now, because I already give a very brief explanation, the simplest one that I can give. We will do more questions, okay, to enhance your understanding. Okay, and then there is a table here, table 2.2. Okay, number of subatomic particle of chlorine. Okay, subatomic particle means particle inside the nucleus. I write for you here, particle inside your nucleus. So actually your electron is not a subatomic particle, but they do mention here, so we just learn lah. Okay, so I say chlorine atom, highlight the word atom. Atom means proton and electron is the same. That's why chlorine have 17 proton and they have 17 electron. But neutron, we need to see periodic table lah, which is we will see the nucleon number. Then you know our nucleon number is P plus n. So if let's say our nucleon number is something, I minus them with our proton, I will get my neutron. Okay, but this scenario is not same in ion. Okay, in ion, your proton will remain just the same. Okay, meaning that, wait, I see. Okay, I write for you here. In atom, proton and electron is the same. Okay, is the same. But when come to ion, okay, in ion, proton and electron is not the same. Why they are not the same? Because ion means they want to achieve stability. So to get stable, okay, so to get stable, for sure their proton won't be same with the atom one. Let's say for ion the proton would be same lah with the atom, but you see for ion, proton and electron is not the same, because they need to capai the balance, so they will be different. But the one that remain, tak kisahlah atom ke ion ke whatever pun, between atom and ion, proton and neutron will always be the same. The changes only will occur in electron. Okay, not the same. Okay, ni satu. So you can say between proton and neutron, whether they are atom or no lah, whether they oh no, they will remain the same, they will be the same. Okay, so let's say I have sodium atom. If let's say my sodium atom have 11 protons, when I say sodium ion also they have 11 protons. For neutrons, let's say I say my sodium atom have 21. Let's say lah, I tipu saja. Let's say they have 21 neutrons. So my sodium ion also have 21 neutrons. Understand? The change will occur in electron. Why they occur in electron? Because electron kena balance in ion. You understand? So I hope you understand what I'm talking about. So tak perlu repeat lah banyak kali. Okay, always remember, atom and ion, they will have same number of proton and number of neutron, but they will change in number of electrons. Okay, so I hope you understand what I'm teaching in this lesson. Okay, I will meet you in another one lesson, okay, which I'm going to teach to you on activity 2.5. Okay, we are going to do the standard representation. Okay, so I think this lesson is all good. We just need to do some minor exercises, then it will be good enough lah for us. Okay, so that's it from me for this lesson. That's all. Bye bye.